Hello everyone, this is Shyam Babu, Assistant Professor, Electronics and Communication Engineering, MLR Institute of Technology, Hyderabad. Today we are going to discuss the topic is double sideband suppressed carrier. Then what is the double sideband suppressed carrier? Then what is the importance of double sideband suppressed carrier? How the carrier should be suppressed? What is the advantage to suppress the carrier? And what are the some disadvantages of double sideband suppressed carrier? Then, in this topic, in this lecture, we discuss about what is DSB-SC. The full form of DSB-SC is double sideband suppressed carrier. After that, what are the advantages and disadvantages of double sideband suppressed carrier? Then, we start. What is double sideband suppressed carrier? Before going to discussing about the double sideband suppressed carrier, first of all, you need to learn or you need to understand the topic or you need to analyze the equation of amplitude modulated signal. Because this is the amplitude modulated signal, just observe here, in this equation, it consists the three terms. This is the first term and second and this is the third term. Observe here, in this case, the AC cos omega ct, it is nothing but a carrier, and AC by 2 cos omega c plus omega m into t, it is nothing but a upper sideband, and AC by 2 cos omega c minus omega mt, it is nothing but a lower sideband information. For example, if you take, this is the carrier frequency and this is Fc, and the upper sideband frequency nothing but Fc plus Fm, this is the Fc plus Fm, this is USB, and this is carrier frequency, and this is, for example, lower sideband, this is Fc minus Fm. That means the AM consists the carrier frequency, upper sideband and the lower sideband. As per definition of message signal and carrier signal, the message signal consists the information. The carrier signal does not consist the any information. But to processing the AM, we need a carrier. That's why in the case of AM, we consider the three terms: carrier, upper sideband and lower sideband information. As of our knowledge, the carrier does not consist the any information. If you reduce the carrier, then automatically the information is we are getting with the help of the sidebands. Then you can suppress the carrier. Any methods are available means automatically the possible method is a double sideband suppressed carrier. Then here, what is the meaning of any information is lost? Because the carrier does not having any information. That's why if you suppress the carrier, automatically the information is passing to the outside. And another advantage of to suppress the carrier means, here observe the point, the percentage of power saving in DSB-SC with respect to AM is 66.67%. The percentage of power saving in DSB-SC is 66.67%. What is the meaning? Remember, 100% of power. On that case, 66.67% should be saving in with respect to the DSB-SC means in the AM, comparing with the AM. Remember, the carrier contains some amount of power. That power can be suppressed because it does not contain any information. Then automatically, if the carrier is there, if the carrier is not there, we got the information by using the DSB-SC and we have the major advantage. The power saving is also there. Therefore, we go for the double sideband suppressed carrier. Then the carrier is suppressed means, what is the remaining things? Only we have the sidebands information. Those sidebands should be, one is upper sideband and second one is lower sideband. The carrier is suppressed. The carrier is suppressed. Then, what is DSB-SC? How we can get the DSB-SC output? Observe here, the message signal m of t, that is equal to mathematically AM cos omega m into t, and you have the carrier signal C of t is equal to AC cos omega c into t. Then these two are given to the DSB-SC modulator. These two are given to the DSB-SC modulator. Then the output should be S of t, that is equal to m of t into c of t. What is m of t? AM cos omega mt into AC cos omega ct. That is the output of the DSB-SC. Because just only you can product the message signal and the carrier signal, then we got the output should be S of t, that is equal to DSB-SC. That's why the DSB-SC modulator is also called as a product modulator, because only the product is happening between the message signal as well as the carrier signal. That's why DSB-SC modulated signal is a product of carrier as well as message signal. Then observe the conditions. The frequency of the carrier signal is greater than frequency of the message signal. That means FC should be greater than FM, or omega c is greater than omega m, because omega c is 2 pi fc, omega m is 2 pi fm. Then the next condition should be amplitude of the carrier signal is greater than amplitude of the message signal. That means amplitude of the carrier is AC and amplitude of the message signal is AM. AC is greater than AM. By following these two conditions, we got the output of the DSB-SC signal with a suppressed carrier. Then observe here, for doing of this analysis, consider m of t, that is equal to AM cos omega mt, AM cos 2 pi fmt, because omega m is nothing but 2 pi fm. And fm is the frequency of the message signal, AM is the amplitude of the message signal. After that, you can take the carrier signal C of t, that is equal to AC cos omega ct, that is equal to AC cos omega c is nothing but a 2 pi fc into t. Fc is nothing but a frequency of the carrier signal, and AC is nothing but a amplitude of the carrier signal. That means this is the mathematical representation of the message signal and the carrier signal. But graphically or diagrammatically, you can represent the m of t is nothing but a message signal. It is a low frequency signal, and this is the message signal representation. This is m of t, message signal, and this is amplitude level. And if you go for the carrier signal information, the carrier signal representation should be observed here. This is the amplitude and this is C of t. That means, what is the fundamental difference graphically? The message signal, the width between the cycle should be more, and the carrier signal, the width is less, because the carrier is a high frequency signal and the message signal is a low frequency signal. But our information is passing through the message signal only, not for the carrier. But the definition of the modulation explains to transmit the message signal to a long distance is possible with the help of the carrier. Therefore, it is a high frequency you are transmitting, okay, but what is the main drawback? It does not consider any information. The power wastage is also happening. Then you can suppress this carrier. Then automatically the power saving point of view, it is helpful. Therefore, you need to suppress the carrier. The first method is double sideband suppressed carrier under amplitude modulation techniques. Observe here, I am multiplying these two. S of t is equal to m of t into C of t. You know very well, m of t is nothing but AM cos omega mt. C of t is nothing but AC cos omega ct. AC cos omega ct. You can multiply these two, then automatically what happens here? AM AC cos omega mt into cos omega ct. If you take this one, AM AC by 2 cos omega mt cos omega ct. 2 cos omega mt into cos omega ct. Then observe here, automatically 2 cos A cos B. 2 cos A cos B. That's why AM AC by 2 cos of omega c plus omega m into t plus cos of omega c minus omega m into t. Observe here, when you are extending this equation, what happens here? AM AC by 2 cos omega c plus omega m into t plus AM AC by 2 cos omega c minus omega m into t. That means observe here, this is upper sideband omega c plus omega m and this is lower sideband. There is no carrier. There is no carrier. Only two sidebands are there. That's why it is called as a double sideband suppressed carrier. Double sideband suppressed carrier. Then just compare with this is AM equation, and if you go for DSB-SC of t, what happens here? AM AC by 2 cos of omega c plus omega m into t plus AM AC by 2 cos of omega c minus omega m into t. Just compare these two equations. For example, this is equation 1 and this is equation 2. Equation 1 is related to amplitude modulated signal and it is also called as DSB-SC. What is that? The double sideband full carrier. The carrier is present. And here the second equation should be DSB-SC. Double sideband suppressed carrier. Just compare these two equations. What is the main difference means? Here upper sideband is there in the case of AM. In the case of DSB-SC, upper sideband is there. In the case of AM, the lower sideband is there, and in the case of DSB-SC, the lower sideband is there. But only the difference is, in the case of AM, the carrier signal is there. Here, there is no carrier signal in the case of DSB-SC. In the case of DSB-SC. That's why the carrier is missing and both sidebands are available. That's why it is called as a double sideband suppressed carrier. Double sideband suppressed carrier. Then, what are the advantages and disadvantages of double sideband suppressed carrier? Once, it is a simple modulation technique. What is the meaning of simple modulation techniques means? This is called as a product modulator. You know very well, the product modulator means just a multiplication of simply message signal as well as carrier signal, and the output should be equal to DSB-SC. There is no much difference. That's why it is simple modulation technique to understand. Here the next advantage is sidebands do not require filtering during this type of modulation. There is no need of filtering techniques because it is either needing of filter means require a circuit. That complex circuits, for example, filtering circuits not needed in the case of DSB-SC. That's why the sidebands do not require filtering during this type of modulation. Then the third important advantage is power wastage is less compared to DSB-SC. Already we discussed previously. Its savings 66.66% of the frequency power. What is the important to reduce the power means? The power saving is the very important factor. With low powers, we are transmitting a signal, we are passing the information. This is the advantage. It is possible with the help of DSB-SC. Therefore, without carrier, the carrier power should be reduced. That's why the power wastage is less comparing with the double sideband full carrier for a modulation scheme. But what are the disadvantages? It contains less carrier information about the carrier. It contains less carrier information because the carrier, what is the main advantage of the carrier? When you are giving to carrier with the modulating signal, nothing but a message signal, then with the help of this one, the modulating signal should be passing through a long distance. Therefore, on that point of view, on that point of view, simply it is considered a small disadvantage. It contains a less carrier information about the carrier. And here detection process is complex. What is the meaning of detection? When you're doing the demodulation process of DSB-SC, is a coherent detection. On that case, it is a little bit tough. And here more bandwidth than SSB. In coming session we discuss the bandwidth requirement, because in the case of AM, the bandwidth should be equal to 2 FM, because the higher frequency to lower frequency, the difference, then the bandwidth should be equal to 2 FM in the case of AM. Likely in the case of DSB-SC also, the bandwidth should be equal to 2 FM only. What is the reason? Means considering the two sideband differences, upper sideband frequency minus lower sideband frequency, then that should be equal to same as the amplitude modulated signal. Therefore, but compared with the single sideband, on that situation, the bandwidth is more. The bandwidth is more. That's why more bandwidth than the SSB. This is the one disadvantage. Therefore, what the topic we discuss? What is DSB-SC and how the DSB-SC signal can be generated with the product modulator. After that, what are the advantages and disadvantages of the DSB-SC? These things is covered in this session. In the next session, we discuss it regarding modulation and demodulation methods of DSB-SC. Nothing but what are the DSB-SC generation methods and DSB-SC detection or demodulation methods. Thank you.